Born in Siberia, the last of 14 children, Dmitry Mendeleev revolutionized our understanding of the properties of atoms and created a table that is probably in every chemistry classroom across the world. In the late 1860s, Mendeleev began working on his great achievement, the periodic table of elements. By arranging all of the 63 elements, then known by their atomic weights, he managed to organize them into groups possessing similar properties. Where a gap existed in the table, he predicted a new element would one day be found. He was very accurate in his predictions, which led the world to accept his ideas about periodicity and a logical periodic table. Mendeleev understood the periodic law. The periodic law just states that when arranged by increasing atomic number, the chemical elements display a regular and repeating pattern of chemical and physical properties. Atoms with similar properties appear in groups or families on the periodic table. These are the vertical columns. They are similar because they all have the same number of valence electrons, which governs their chemical behavior. Valence electrons are the outermost electrons of an atom. These are important in determining how the atom reacts chemically with other atoms. Group 1 is known as the alkali metals. They are very reactive, especially with water, and they have one electron in their outer shell. Group 2 is the alkaline earth metals. They're reactive, but not as reactive as the alkali metals. They have 2 electrons in their outer shell. The groups in the middle are called the transition metals. They can hold up to 32 electrons in their second to last shell, but we don't really consider them when doing our patterns of valence electron on our periodic table. Group 3 is known as the boron family. The boron family has 3 electrons in their outer shell. Group 4 is known as the carbon family. The carbon family has 4 electrons in the outer shell. The nitrogen family is group 5. They have 5 electrons in their outer shell. The family with 6 electrons in the outer shell is the oxygen family, or group 6. You would think group 7 would be the fluorine family, but it's named the halogens. They have 7 electrons in the outer shell. They are very reactive and often bond with elements from group 1, or the alkali metals. The noble gases are group 8. They have a full outer shell of valence electrons. These 2 periods are known as the rare earth metals. Here's one more look at the valence electron patterns in your periodic table. The horizontal rows, also known as periods, have the same number of energy levels. Rows 1, 2, 3, 4, and 5 have the same amount of energy levels as their corresponding row number. This is helpful when identifying a Bohr model of an atom. First, count the energy levels. Since this one has 3, it will be in the 3rd period. Then, count the valence electrons. This one only has 1, so it will be located in the alkali metal family. This is a Bohr model of sodium. This Bohr model has 3 energy levels, which means it will be located in the 3rd period. There are 6 valence electrons, and we know that it will be located in the oxygen family, or group 6. So this is a Bohr model of a sulfur atom. There is a zigzag or staircase line that divides the table. The elements that touch this zigzag line, except for aluminum, are known as metalloids. All of the elements on the right-hand side of the metalloids, including hydrogen, are known as nonmetals. All of the elements on the left-hand side of the metalloids are known as the metals. Metals are mostly solids at room temperature, except for one, that's mercury. Metals are also lustrous, malleable, ductile, and good conductors of heat and good conductors of electricity. Nonmetals are the opposite of metals. Most of these are solid, but many of them are gases. Bromine, however, is the only liquid. They are dull, they are brittle, and they are non-conductors of heat or electricity. They're also known as insulators. Metalloids are often referred to as semi-metals. They have characteristics of both metals and nonmetals. They are shiny but brittle, and they are semiconductors.